Imagine a river in the sky, a powerful current of air, thousands of miles long, racing at over 200 miles per hour. This is the jet stream, flowing high above us where commercial jets often fly to catch a free ride. It's the engine of our planet's weather, separating cold polar air from warm tropical air. Think of it as a planetary fence, keeping two weather worlds apart. But this river doesn't sit still, it meanders, driven by Earth's rotation and the temperature difference between the poles and the equator. When the jet stream flows straight, our weather is predictable, seasons follow their rhythm, and life feels stable. But when it bends and twists, everything changes. The jet stream steers storms, directs air masses, and decides if your day is sunny or stormy. A dip can bring Arctic chills. A bulge can deliver a heat wave. For centuries, we only saw its effects. Sudden storms, droughts, baffling shifts in temperature. Now, with modern meteorology, we can track and understand this invisible force. The jet stream is not just a weather phenomenon. It's a vital part of Earth's circulatory system, distributing energy and shaping our climate. Without it, the world as we know it would be unrecognizable. It's a testament to the interconnectedness of our planet. What happens when this river of air becomes unstable? Imagine it developing huge, dramatic waves, veering sharply north or south. These are Rossby waves. When they grow large and slow, they lock weather patterns in place. A northward bulge or ridge can create a heat dome, trapping hot air and turning a warm spell into a dangerous heat wave. Conversely, a deep southward plunge or trough opens a channel for Arctic air, unleashing a polar vortex and a deep freeze. The jet stream, usually a conveyor belt, becomes a meandering serpent, causing persistent extremes. This shift from a straight, zonal, to a wavy, meridional flow is behind many of today's most extreme weather events. It's not just about one hot day or cold night. It's about relentless, stuck conditions. When the jet stream jumps its banks, the weather below can become trapped for weeks. The result? Heat waves, cold snaps, and a world turned upside down by a river in the sky. The persistence of these patterns is what makes them so dangerous. To understand why the jet stream gets so wavy, we look to the North Atlantic Oscillation, or NAO, a giant atmospheric seesaw. On one end, near Iceland, is a permanent low-pressure system. On the other, near the Azores, a high-pressure system. The NAO measures the pressure difference between these points, and this difference shapes the jet stream. In a positive NAO phase, the pressure difference is large, the jet stream is strong and straight, and mild wet winters hit northern Europe. In North America, this often means warmer, less stormy conditions in the east. But in a negative NAO phase, the pressure difference weakens, the jet stream slows and meanders, and those big wavy loops appear. This opens the door for extreme stagnant weather across Europe and North America. The negative NAO is the troublemaker, allowing polar and tropical air to invade each other's territory. Cold air from Greenland can pour south into the US, while warm air from Africa surges north over the UK. A simple switch in atmospheric pressure, but its consequences are felt by millions. The NAO's mood swings set the stage for dramatic weather shifts. The jet stream's path is at the mercy of this Atlantic seesaw. When the NAO flips, so does our weather. The summer of 2025 in the UK was relentless. Weeks of suffocating heat, a classic sign of a blocked jet stream stuck in a negative NAO. A stubborn ridge of high pressure parked over Western Europe, pulling scorching air from the Sahara and trapping it over the British Isles. The familiar cycle of sun and showers vanished. Instead, cloudless skies and temperatures over 100 degrees C gripped even northern cities. Lawns turned brown, reservoirs shrank, and the government issued its first ever national red alert for heat. Britain, built for damp chill, was suddenly living in a Mediterranean climate, without the infrastructure to cope. The jet stream, which should have brought cooling breezes and rain, was diverted far north, sending storms to Iceland instead. The air grew stagnant and polluted, making the heat dangerous, especially for the vulnerable. It felt as if the planet's air conditioning had broken down. The heat wave became a defining moment, a tangible lesson in how a distant atmospheric shift can transform daily life. The invisible river in the sky had bent, and Britain sweltered in a summer that forgot how to cool down. The event was a stark warning of a changing climate. As autumn fell in the US in 2025, a different drama unfolded. A deep, punishing trough in the jet stream. The same negative NAO pattern that baked Europe now unleashed Arctic air on Central and Eastern America. The jet stream dove south over Canada, creating a superhighway for polar air to invade the Midwest. Cities like Chicago and Minneapolis plunged from mild autumn to deep freeze in a day. Temperatures dropped 50 degrees Celsius in 24 hours. This wasn't just an early cold snap, it was an Arctic invasion. Brutal winds brought wind chills below -30 degrees, and the Great Lakes produced historic lake-effect snow. Buffalo was buried under feet of snow before Thanksgiving. The deep freeze was a brutal reminder of the jet stream's power, trapping cold air and leaving millions shivering. The same atmospheric traffic jam that baked Europe froze America. Let's zoom in on two lives shaped by the same wobbly jet stream in 2025. In London, Anya, a paramedic, faced a summer of constant sirens. Elderly in overheated flats, workers collapsing from heat stroke, children with asthma attacks. The city's Victorian buildings trapped heat, and the underground became a sweltering ordeal. Water restrictions withered gardens, and the relentless heat left Anya exhausted. For her, the jet stream's northward jump was the oppressive heat that defined every day. In Chicago, Marcus, a snowplow driver, was caught in the jet stream's southward plunge. Instead of a quiet November, he worked 16-hour shifts battling a historic snowstorm. The polar vortex descended, winds howled, and snow buried the city. Marcus missed family events, worried about stranded drivers, and felt the weight of keeping his city moving. For Marcus, the jet stream's deep trough was the biting wind and endless snow. For both, the jet stream's wild swings were not just weather, they were life, transformed. Anya and Marcus's stories reveal the human cost of an erratic jet stream. Persistent heat waves strain healthcare, spike mortality, and devastate crops and livestock. Polar plunges cripple infrastructure. Power grids fail, pipes burst, and transportation halts. Economic losses from a single extreme event can reach billions. Beyond the physical damage, there's a psychological toll: constant anxiety, disrupted routines, and canceled traditions. Vulnerable communities suffer most: low-income neighborhoods, the elderly, and those without climate control. Outdoor workers and people with health conditions have no escape. As the atmosphere grows more unstable, these extremes magnify existing inequalities. The cost is measured in lives, health, and justice, not just dollars. A wobbly jet stream is a magnifying glass for society's vulnerabilities. The rhythm of life is disrupted, and our sense of security erodes. The stakes are rising as the sky grows wilder. The good news: we're not flying blind. Advances in meteorology and satellites let us monitor the jet stream in real time. Scientists track pressure systems, spot negative NAO phases, and run models to predict when the jet stream will jump its banks. This gives us warning, enough to open cooling centers, prepare utilities, and protect the vulnerable. A timely forecast can turn disaster into a manageable challenge. Predicting a polar plunge lets road crews, airlines, and schools prepare. Most importantly, it gives the public time to get ready and stay safe. As the Arctic warms, the jet stream grows weaker and wilder. Investing in meteorology is building a global early warning system. Reading the sky is our first step toward resilience. The jet stream story in 2025 is a glimpse of our future on a warming planet. As the Arctic warms, the jet stream grows less predictable. Stuck ridges of heat and deep troughs of cold become more common. This new reality demands a shift in how we build and plan. Our infrastructure was designed for a stable climate. Now, we must adapt it for extremes. Cities need more green spaces, and energy systems must handle both heat waves and freezes. But adaptation isn't enough. We must tackle the root cause: global warming. The jet stream wobbles because we're changing the temperature difference that drives it. Reducing greenhouse gas emissions is the most powerful way to restore balance. The jet stream is a messenger, connecting Arctic ice to London's heat and Chicago's snow. By understanding its message, we can prepare, adapt, and act. We all share the same sky. Our choices today shape tomorrow's weather. Watching the wild wind is not just science, it's survival.